Good morning. Hey guys, sorry I wasn't in class yesterday. If you didn't see my message, I inboxed everybody, but unfortunately I'm quarantining, as I mentioned, until Tuesday of next week. So if you have questions, reach out to me, of course, and just be diligent about staying on top of things. But I have confidence that you will do just fine. If you need to do, retakes on the Canvas quizzes or resubmit your homework assignments, that you can do that. Okay, well, let's take a look. Today's notes, 5.2. So what we're going to do today is we're going to look at equations, but not necessarily systems, okay? So if you look down at the bottom, you can see that this is just a regular equation, 3x minus 4 equals 5. And usually we would just go about solving that, right? Well, as things start to get more complicated, like you'll see down here, this is an equation as well. Sometimes it makes sense to actually use it as a system of equations and allow Desmos to do the work for us. So the first thing that you need to remember is that a solution to a system is when the equations intersect. Okay? So if I graph a system of equations, where the two lines touch is where my solution is. So let's take a look at the first example and I'll show you what I mean. Okay, let's say that, for instance, you forgot how to solve an equation. Well, I'll just show you. You could add 4, right? And that would give you 3x equals 9, and then divide by 3, so x equals 3, right? And so that should be your solution. Well, what you can do if you forget how to do all of that is actually plug it into Desmos by splitting up the equation. And what I mean by that is split up the left side and the right side. So the left side here, 3x minus 4, okay, notice there's no y value up here, so there's only one variable. That's what allows us to do this, okay? So one variable, so I'm going to split it up and say that's the left side, okay? And then I'm going to say the other side is y equals 5. That's the right side, okay? So we're splitting it up into two components here. All right, so now, because I've split it up, that allows me to graph. So 3x minus 4 starts at negative 4 and goes up 3 over 1, up 3 over 1, rise over run, up 3 over 1, okay, and it continues all the way up. And then, I'm going to grab this and yank it over here, okay, and then your second one, of course, is y equals 5, which is up here on the y-axis at 5, okay. Now, where do those two lines touch? They touch right here, okay, which would be at the point 3, 5. That's my x value, my y value. So where is the solution? Now, here's the one difference that we haven't really discussed, but in a regular equation where there's only one variable, then our solution is just going to be that variable. So in this case, it's 3, right? Okay, whereas earlier this week we were doing ordered pairs, which isn't wrong. It's just this doesn't really ask for a y value. It's only asking for the x value. Okay, so we can do the same thing no matter how complicated the equation is. Again, this one's got fractions, so if I were to solve it algebraically, it could get pretty ugly pretty quickly. So instead, I'm going to allow Desmos to do the work for me. Or if you prefer to work by hand, you can do that also. So negative 2/5 x plus 1 and 3/5 x minus 4. And now I'm just going to graph those. Okay, so let's pull up Desmos. Sorry. I'm allergic to good math work. Just kidding. Okay, so y equals 3 over 5 x. Whoopsies. Click to the side. X minus 4. And y equals negative 2 over 5 x. Again, click to the side. Plus 1. Okay, there you go. Now you can see my graph, okay, and where it intersects, which is right here. And that point would be where x is 5. Okay, so you don't necessarily have to graph it here even to show where the solution is. Okay, all right, as we continue, again, same thing, negative 2x plus 4, negative 2x minus 1. Wait a second. If you recall, we talked about this in class. This has the exact same slope. What kind of lines have the exact same slope? Okay, should we treat it like Blue's Clues? Nice job! Yeah, so it is, they should be parallel lines. And remember, parallel lines never touch. So if that's the case, then this should be no solutions. And we know that, again, just because the slope is the same. And voila. Look at that. Parallel lines never touch, no matter how far you zoom in or out. They look like they get closer, but it's only because of the axes. So this is actually no solutions. It never touches. Okay. All right. So moving right along. So we've got examples with no solutions. We got examples with singular solutions, right? So when you get something that's really complicated looking like this one, this is where this comes into benefit, right? I'm going to draw a line straight down through the equal sign, and that's just so I know which side is the left side of the equation and which side is the right side of the equation. Okay? Again, notice it's only one variable. There's only an x up there, so that allows me to separate it and say this is the same thing as saying y equals -2 in parentheses 3x minus 2 plus 2, or plus 4, I'm sorry. And then on the right side, we're going to copy down the pink. So 9x minus 2, 6 minus x, plus 1. Okay? All right. So the solution to our equation is, once you plug it in, let's see here, y equals -2 outside the parentheses, 3x minus 2 inside the parentheses, plus 4. And y equals 9x minus 2, parenthesis, 6 minus x equals, or plus 1. Okay, and there we go. Click it. Woo! Weird numbers, but it's accurate. Okay, see, sometimes it's not the easiest to look up. So our solution of this equation would be 1.118. Weird number, right? Okay, so we kept it short and sweet today. You're solving a system, or well, you're solving an equation by turning it into a system, right? This is just a regular equation, but we turned it into a system and allowed Desmos to graph it for us. Okay, so that's the big thing. And just again, when you're solving an equation, you only get one part of the solution, the x value. If you're solving a system, you should have an ordered pair. Okay? So you got an exit ticket. Go ahead and complete that. Also, go back through and make sure that all your previous homework is completed as well. And, of course, reach out to me if you have any questions. I've gotten a few students now who have sent me screenshots of their work, so I'm working on that this morning just to catch up and make sure you know what you're doing. So I will talk to you guys all soon. I miss you.